All right, so let's start number 19, and I kind of set up this problem here. They said we have 200 students, so that's why I have 200 in the grand total. And it says of the 80 males, so that's why there's a total of 80 males. 60 have brown eyes. So I don't know how many boxes there are, but I know if 60 have brown eyes, 20 do not have brown eyes. So I just divided into a 2 by 2. It said if eye color and gender are independent, how many student surveys would have brown eyes? So this is what I want to do right here. Okay, so the key word here is independent. Okay, so I tried to finagle this, right? I know that if this is 80 and this is 200, I know that this must be 120. That I know. All right? But it still doesn't help me get the females in the brown circle. So I got to use the word independent. And so I know that there's a couple of formulas for independent. And the D-list, I'm going to do the probability of brown, given that they are male, is equal to the probability that she has brown eyes. Okay? That's one of the independent deals. So let's go do this. The probability that somebody has brown, given that they are a male, so the deal is I have 80 males, and the probability that somebody has brown eyes is 60. Okay? Excuse me, I know that they're equal because they told me they're independent. Okay, what's the probability of somebody having brown eyes? Okay, well that is what I have to find out. So I know whatever that is, that's going to be x over 200. All right, so I'm just going to cross this out. I got 6 over 8. So now I'm going to cross multiply, so I get 8x is equal to 1200. X is equal to 1200 divided by 8, and I get 150. That's great. I get 150. All right, that's how many brown eyes they are, because the probability of brown is 150 divided by 200, right? 150 divided by 200. All right, so if there's 150 people have brown eyes and 80 of them are males, then 90 is female. So the answer is D. Now I think that one took a lot of work. Unless you were pretty intimate with this one, I would probably skip this. Okay, so they want to know which is the most appropriate test. And so let's go look at this. We have proportions. And so that means I have categorical data. So if I have categorical data, it's not a t-test, okay? And so is 0.5. The principal of a local high school believes that the portion of students with elevated blood pressure is greater than 0.5. Okay, do you see I just have one variable, and it's blood pressure. So it's not a chi-squared, because chi-squared is two variables, like maybe blood pressure and whether or not you're a student or you're an adult. Okay, so now I decide, are they just doing like boys and girls who have blood pressure? That would be two props, or is it just students? And it's just students, so the answer is A. Okay, so they want to know which of these following things is correct. And so let's talk about what IQR is. Hopefully you remember that. That is Q3 minus Q1. So that's going to be 1806 minus 1704. And I do the math on that, that's 102. So it's none of these guys right here. And so let's look at my standard deviation is 61. So the answer is A. Okay, so let's talk about this. If I have a 90% confidence interval, alpha is equal to 0.100. So if alpha is equal to 0.100, then we will reject HO. And if I reject HO, then I know that U1 is greater than U2. Okay, this does not contain 0. Okay, now 95% alpha is equal to 0.05. So if I have alpha is equal to 0.05, again I'm going to reject HO, right, because my p-value is 0.03. So I'm going to reject my HO, and the same thing, mu1 is greater than mu2. Okay, let's go to 99%, and there alpha is equal to 0.01. So if alpha is equal to 0.01, and I have a p-value of 0.03, I'm going to fail to reject. And if I fail to reject, what do I know? That HO is true. Well, let's talk about HO. So that means that U1 is equal to mu2. That means there is no difference. And so if there is no difference, it contains 0. So 3 is the only correct answer, so the answer is B.